Somewhere in Dubai, right at this very moment, someone is turning on a tap, and clean, cool, fresh drinking water is pouring out of it. There is nothing remarkable about that at all, until you stop for just a moment and ask one very simple question. Where did that water actually come from? Because Dubai sits in one of the driest places on the entire planet. It gets almost no rain. It has not a single river. The ancient groundwater buried beneath it is limited and running steadily lower. By every natural measure that exists, this is a land that simply should not be able to support a great, thirsty city of millions of people. It should be near empty desert. And yet the taps run freely, the fountains dance, the swimming pools fill to the brim, and the lawns and gardens stay a lush, improbable green. So where does all of that water come from? And the answer is every bit as audacious as the city itself. Dubai drinks the sea. Very nearly every single drop of fresh water in the entire city, well over 99% of it, does not fall from the sky and does not rise up from the ground. It is manufactured on a colossal industrial scale by taking the salt water of the Persian Gulf and tearing the salt right back out of it. This is the story of how a desert megacity taught itself to drink the ocean, the staggering hidden machine that makes it all possible, and the slow, salty, creeping problem that this very machine is quietly creating in the sea just offshore. Let me start with just how genuinely dire the natural situation really is, because it is the key to everything that follows. The United Arab Emirates is one of the single most water-scarce countries anywhere on Earth. It receives only a few scant inches of rainfall in a typical year. It possesses not one permanent flowing river, and the groundwater held deep in the aquifers beneath the desert sands, water that took many thousands of years to slowly accumulate down there, is strictly limited and is being pumped out and used up far faster than nature could ever hope to refill it. And yet this is a nation of well over 10 million people, with some of the very highest rates of water consumption per person to be found anywhere in the world. The average resident of Dubai gets through well over 250 liters of water every single day, for drinking, for washing, for their gardens and their pools, and for the endless construction that never seems to stop. So put those two facts together. You have a near waterless desert on one side, and on the other, one of the very thirstiest populations on the entire planet living right on top of it. Something absolutely enormous has to bridge that vast and impossible gap, and that something is desalination. It is worth pausing to remember that, just as with the cooling, it was not always this way. For all the long centuries before oil, this coast survived on water alone in the hardest possible way. The settlements here were small, and they clustered tightly around whatever scarce fresh water could be found, a handful of precious wells, the occasional desert oasis, and, in some places, ingenious ancient channels that carried groundwater down from distant mountains. Water was the single most precious substance in the region, rationed and treasured, and it could only ever support small communities of pearl divers, fishermen, and traders living lightly on the edge of the sand. The desert simply could not feed a great city, because the desert could not water one. And that, more than anything else, is what changed. When the oil wealth arrived in the middle of the 20th century and the first great desalination plants were built along the coast, the ancient limit was suddenly shattered. For the first time in human history, the population of this coast was no longer capped by the trickle of water from its wells. The sea itself became the well, a limitless one. And the cities began their explosive climb toward the millions. Desalination, at its very heart, is a beautifully simple idea. You take water that is far too salty to drink, and you remove the salt from it, leaving clean, fresh water behind. Human beings have actually understood how to do this, in principle, for thousands of years. It is the very same basic process as boiling a pot of seawater and catching the steam that rises off it. But doing that at the Titanic scale, required to quench the thirst of an entire sprawling modern city, is a completely different challenge altogether. It demands vast industrial plants, built right on the edge of the coast, sucking in staggering quantities of Gulf seawater and processing it relentlessly, around the clock, every single hour of every single day, without ever stopping. And there are two main ways that these giant plants actually accomplish it, two competing technologies. And the story of Dubai's water is in large part the story of a great shift from the first of them to the second. The first, an older, method is essentially industrial-scale boiling. It is called thermal desalination, and for decades it was the reliable workhorse of the entire Gulf region. The idea is to heat the seawater up until it turns into steam, and here lies the crucial trick. When salt water boils away into vapor, only the pure water actually rises up as steam. The salt itself gets left behind. So you capture all of that clean rising steam, you cool it back down again, and it condenses into fresh, perfectly drinkable water, while the salt remains behind in an ever more concentrated brine. The most common versions of this go by the names multi-stage flash distillation and multiple effect distillation, and they repeat this cycle of boiling and condensing over and over again in a series of stages to wring out as much fresh water as they possibly can. And there was one particularly clever reason that the Gulf fell in love with this method in the first place. These thermal plants were deliberately built right next door to electrical power stations, which meant they could run largely on the leftover waste heat from generating electricity, cleverly using the very same fuel to produce both power and water at the same time. For a region essentially floating on top of an ocean of cheap natural gas, it made perfect economic sense. And even today, in the Emirate of Abu Dhabi, the great majority of desalinated water, somewhere around 84% of it, is still produced in exactly this thermal way. But thermal desalination carries one very serious drawback: boiling that much seawater continuously requires an absolutely colossal amount of energy. And so, over time, the industry has increasingly turned toward a second, and considerably cleverer, method. This second method does not boil the water at all. Instead, it squeezes it. It is called reverse osmosis, and it is a genuinely elegant piece of engineering. Picture an extraordinarily fine filter, a special membrane, riddled with holes so unimaginably tiny that individual molecules of water can just barely be forced through them, while the larger salt particles simply cannot fit and are blocked. Now, take your seawater and push it up against that membrane under truly enormous pressure. The pure water molecules are forced through to the clean side, fresh and drinkable, while all the salt is left stranded behind, unable to pass. That, in essence, is reverse osmosis. No boiling, no steam, no heat at all, just sheer brute pressure and an incredibly fine filter, cleanly separating the salt from the water. And its single great advantage is that it uses considerably less energy than boiling the sea does, which is precisely why, all across the Gulf, and indeed all across the world, reverse osmosis is now rapidly becoming the dominant method of choice. Today, it already makes up the majority of all desalination capacity on the planet, and Dubai is busy building enormous new reverse osmosis plants, some of them ranking among the most efficient ever constructed anywhere. The city is, in effect, right in the middle of switching over from boiling the sea to squeezing it. And the difference between the two, in hard numbers, is stark. The older thermal plants, the great boiling complexes, like the vast Jebel Ali facility in Dubai, one of the largest combined power and water sites anywhere in the world, can burn through more than 5 kilowatt hours of energy to produce just a single cubic meter of fresh water. The newest reverse osmosis plants, by contrast, are pushing that figure dramatically downward. One major new plant coming online in Dubai is designed to produce its water at an energy intensity of under 3 kilowatt hours per cubic meter, a number that would have seemed almost miraculous to the engineers of the earlier era. That may sound like a small technical distinction, but multiplied across billions of gallons a day, for decades on end, it represents an absolutely colossal saving in energy, in money, and in carbon. It is the difference between a city's water being a crushing burden on its power grid and something far lighter and more sustainable. And the sheer scale of all of this is genuinely difficult to comprehend. Across the United Arab Emirates as a whole, desalination plants churn out more than 7 million cubic meters of fresh water every single day, enough to fill many thousands of Olympic-sized swimming pools conjured out of pure salt water every single day. Dubai's own water authority has expanded its production capacity many times over across the decades, and is now pushing toward the ability to produce 750 million gallons of desalinated water a day. And the Gulf region as a whole stands as the undisputed desalination capital of the entire planet. This one relatively small stretch of coastline produces an enormous share of all the desalinated water on Earth. Try to genuinely hold that picture in your mind for a moment. An entire glittering civilization, its running taps, its dancing fountains, its swimming pools, and its green gardens. Running not on any river, or lake, or mountain spring, but on the ceaseless, round-the-clock, industrial conversion of the sea itself into something that a human being can safely drink. But, and by now, if you have been following the strange story of how these desert cities actually work, you can very likely feel this coming. All of that water comes at a real and heavy cost. Because turning seawater into fresh water, whether by boiling it or by squeezing it, takes an enormous amount of energy. And in the Gulf, that energy has, right up until very recently, come overwhelmingly from the burning of fossil fuels. So exactly as with the air conditioning that keeps these cities cool, the great machine that keeps them watered also runs on oil and gas, pumping carbon dioxide up into the atmosphere and warming the very same planet that is steadily making the entire region hotter and, over the long run, thirstier still. It is the very same uncomfortable loop, simply appearing in a different form. Now, to the WUE's genuine credit, it is working extremely hard to break out of that loop. The stated plan in Dubai is for its desalinated water to be produced entirely by clean energy, a combination of solar power and captured waste heat, by the year 2030, a shift that is projected to cut tens of millions of tons of carbon emissions. The ongoing switch to efficient reverse osmosis, powered by the region's one truly abundant natural resource, its blazing sunshine, could genuinely transform desalination from a dirty necessity into something far more sustainable. But that great transition is still very much underway, and for the moment, a great deal of the Gulf's manufactured water still carries a heavy carbon footprint behind it. And then there is a second problem, one that is, in some ways, even more insidious than the first, precisely because it is unfolding so slowly, so invisibly, and right there just offshore. Think it through for a moment. If you are pulling fresh water out of seawater, then whatever is left behind afterward must, by simple logic, be saltier than the water you started with. And that leftover, a hot, heavily concentrated, sludgy salt solution known as brine, has to go somewhere. And where it goes, almost always, is straight back into the sea. For every single liter of fresh water that a plant produces, it pumps out an even larger volume of this super salty brine, often warmer than the surrounding sea, and laced with the various chemicals used to treat the water, discharged right back out into the Gulf. Now, out in the wide open ocean, that brine might well disperse and dilute away without causing too much trouble. But here is the absolutely crucial thing about the Persian Gulf. It is not the open ocean. It is a shallow and very nearly completely enclosed body of water connected to the wider ocean beyond only through a single narrow strait. The water trapped inside it flushes and refreshes itself extraordinarily slowly, taking years to fully cycle through and exchange with the open sea. Which means that all of that brine, from all of those plants, across all of those different countries, all around the Gulf's shores, does not simply wash away and vanish. It accumulates. It builds up. And so the Gulf is, slowly but genuinely measurably, growing saltier over time. And this creates a truly vicious trap, one of the strangest in all of modern engineering. Because the saltier the Gulf water becomes, the harder and the more energy intensive it becomes to pull fresh water back out of it, since you are now forced to start the whole process with saltier water than before. In other words, the very act of manufacturing fresh water from the Gulf is slowly degrading and poisoning the source of that fresh water. These desert nations are, in a very real and literal sense, at risk of slowly salting their own well. The four largest Gulf producers, taken together, generate more than half of all the desalination brine on the entire planet. And beyond just the salt, all of that hot, concentrated discharge puts real and serious stress on the marine life of a sea that is already, naturally, one of the hottest and the saltiest bodies of water anywhere on Earth. And beneath all of that lies one more stark and simple vulnerability, one that echoes the entire precarious bargain that these cities have struck with their own hostile environment. A desert megacity of millions of people possessing essentially no natural water of its own that manufactures very nearly all of its drinking water directly from the sea. Is a city that is utterly and absolutely dependent on those desalination plants continuing to run flawlessly and without pause. And most of these cities hold only a few days' worth of water in reserve storage at any given time. So a serious, prolonged failure of the desalination system, whether from a major power blackout, a catastrophic equipment breakdown, a large oil spill fouling up the seawater intakes, or even a deliberate attack, would not be some minor inconvenience. In a matter of just days, it could rapidly become a genuine crisis of survival for millions of people. The authorities, to their credit, understand this danger very well, and they have taken it seriously. Dubai now pumps a portion of its excess desalinated water down into underground aquifers, effectively banking it away as a strategic emergency reserve to be drawn back up out of the ground if the plants above should ever go down. But the fundamental fact of the matter remains, and it is inescapable. The water, exactly like the cold air itself, can never be allowed to stop flowing. So let me end, as I always try to, with honesty and with genuine balance. Because it would be very easy indeed to frame this entire story as an act of sheer folly, the building of great, thirsty cities in a place where there is simply no water to be found, but that framing would miss the deeper truth of it, and it would not be fair. Desalination is quite genuinely one of the great engineering achievements of the entire modern age. It has allowed tens of millions of human beings to live, and to genuinely thrive, in places that could otherwise never in 1,000 years have supported them, and it has done so reliably, day in and day out, for decades. And the WUA is very much not ignoring the real downsides of it. It is actively and seriously confronting them, pioneering ever more efficient reverse osmosis, racing to power its water plants with sunshine instead of gas, building up its strategic underground reserves, and pouring research into better and less harmful ways of handling all that brine. In a great many ways, the Gulf has become a living laboratory for the entire future of water on this planet, and that, in the end, is the real reason this whole story matters so very far beyond the borders of Dubai. Because water scarcity is not going to politely remain a desert problem for much longer. As the global climate continues to warm, and as populations continue to grow, more and more of the world, including a great many regions that have always simply taken their abundant water utterly for granted, is going to find itself facing its own version of this exact challenge. Desalination is already spreading rapidly all across the globe, and it will only continue to spread further and faster in the years ahead. The Gulf, purely out of sheer and desperate necessity, simply got there first, and in doing so, it is now showing the rest of us both the astonishing promise of manufacturing our water directly from the sea, and the very real and serious problems, from energy to brine, that we will all have to find a way to solve if we come to lean upon it. Dubai drinking the ocean is not merely a marvel of one fabulously wealthy desert city. It may very well be a genuine preview of how a thirstier world learns to survive. So the next time you happen to see those dazzling images of Dubai, the great fountains hurling their water high into the shimmering desert air, the impossibly green lawns, the endless rows of deep blue swimming pools glittering under a sun so fierce it should render every bit of it utterly impossible, I want you to pause and remember where every last drop of it truly comes from. Not from any cloud or river or spring, anywhere, but from the salt sea just offshore, hauled in by the untold millions of gallons and painstakingly stripped of its salt by vast. Tireless machines that never ever rest, not for a single second. Dubai is a city that looked out at a waterless desert sitting beside a salted sea and simply decided that it would drink the sea anyway. It is an extraordinary act of will and of ingenuity and of truly enormous energy, but the sea is slowly growing saltier for it with every passing year. And the machines can never once be allowed to stop, and the same deep question hangs quietly over all of it. The very same question that hangs over the cooling and the heat and everything else about these impossible, glittering cities. Not whether such a thing can actually be done. Because it plainly can be, and it is being done, right now. But rather, how long, and at what ultimate and final cost, a civilization can go on manufacturing the very conditions of its own survival, one single gallon and one single degree at a time.